Welcome to Miss Smith's Math Tutorials. I'm Miss Smith. In this video, we're going to be talking about finding distance, but we're specifically talking about when we're shown a graph and we're asked to determine distance from one point to another from looking at a picture instead of, being just handed 2 points and told to find the distance. So our instructions for these two examples say, find the area and the perimeter of each shape. Okay, so looking at this first example, we know that, so there's two things I need to find. I need to find area and I need to find perimeter. So for area, it's actually not too bad as long as we can remember the formula for area of a triangle. So that is one that we do expect you to have memorized. So area of a triangle would be 1/2 times the base times the height. Okay, so I would need to know what is the distance of the base, what is the distance of the height, and multiply both those together and also by 1/2. So I can do that fairly easily. The distance of the base is pretty easy to find. I can just count these units and that'll tell me the distance of the base. So I've got 1, 2, 3, 4, 5, 6. Easy enough. So I know the base is 6. So the height, that would be from the bottom of the triangle all the way to the tippy top of the triangle. Again, I can easily count these units. So I go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep. So the height from here to here, you can note that just with a little dotted line if you like. From here to here is 5. Okay, so I've got all the information I need to plug into that formula. So area equals 1/2 times the base, 6, times the height, 5. And then that I can just put right into my calculator. So, is it on? Nope. Okay. 1/2 times the 6 times 5. All right, and I see that my area is 15. So my area is 15. Okay. There is part 1 of my answer. So I've got area down, done. Still need to find the perimeter. So we should remember that perimeter means adding up all the sides together. So the bottom was really easy to figure out the distance. All I had to do was count the units. Figuring out the sides, because these are slanted lines, it's not that easy. I can't just kind of guesstimate and say, okay, it goes across 1, 2, 3. You can't do that. When it's a slanted line, we have to know the exact distance. So we're going to use that distance formula that we learned back in the first video on this unit. Okay, so if we remember correctly, distance formula is D equals, I've got x2 minus x1 squared plus y2 minus y1 squared, all under a square root. Okay, so I need to pick out these 2 points, figure out what these 2 points are, plug them into my formula, and solve. That will tell me my distance from here to here. Now, the nice thing about this triangle is that I can clearly see that it is evenly distributed. So I know the length of this side is going to be equal to the length of this side. You're not always going to know that, okay? It's not always going to be as clear as it is on this calculator. Sometimes you're just going to have to test it out, and it might even be like a decimal place difference between them. Here, it's pretty clear cut that these two are in fact even. But just so you're aware, you can't always just make that assumption. You really have to count it out and see, are these sides evenly spaced? Okay, so I really only need to find one side because I know the other side will be equal. let's pick out this point. So this point falls at -2, -2. So that's my first point. -2, -2. And I want to know the distance to this point. So that would fall at 1, 3. Now you might say, well, what if I had picked this point first and then I went, instead of from here to here, I went from here to here. That does not matter. So the order of the points doesn't matter. It's just making sure we're labeling them consistently that matters. Okay, so remember we talked about this back on the first video that we need to label each part of our points. So this is our first x, so we're going to call this x1. This is our first y, so y1. This will be our second x, so we'll call it x2, and this will be our second y, so we'll call it y2. Okay, so now that we've got everything labeled, we can plug it up in here to that formula. So we've got d equals the square root of x2, which we said is 1, minus x1, which is 2. Now minus and negative, I know that reduces to a positive, so I'm going to go and change that to a plus. All right, y2, 3, minus y1, -2. Again, a negative and a negative make a positive. Okay, now this, I can either try to solve it by hand or I can go ahead and put it in the calculator, which is what I'm going to do. So I'll do my square root, 1 plus 2 squared plus parenthesis 3 plus 2 squared. All right, I'm going to double check just to make sure I typed it in right. It's worth that second check and enter. Now you're going to get a long decimal. We're going to round it. We're going to use common sense and just round it to the nearest tenth. Okay, so I'm going to do 5.8. So the distance would be 5.8. So that means from this point to this point is 5.8. Now because this triangle is an isosceles triangle, this one is also 5.8. Okay, so now I have all the information I need to be able to add up this side, and this side to tell me my perimeter. So I would have, I'm just going to do it on the calculator, 5.8 plus 5.8 plus 6. All right, that gives me 17.6. So my perimeter okay, 17.6. All right. In this next example, we've got a quadrilateral. So I would not expect students to know this by any means. We would give it to them. But an area of a quadrilateral formula would be 1/2 times the height times the first base plus the second base. Okay. So that would be the formula we would use to find area. So let me think about what I already know in that formula. So I've got my 1/2. I can go ahead and write that. So 1/2 times the height. So that means from the bottom to the top. Well, luckily this is a straight, kind of dead on shape with my graph. So I can actually count, just like we did here, to find the height. So let's see. So from the top all the way to the bottom, let's count how many units. 1, 2, 3, 4, 5, 6. So the height would be 6. So times 6. All right, now times the first base. So this would be one base and that would be another base. It doesn't matter which one you pick as base 1 and base 2. You would just pick one and then do the opposite the second time. So let's start with just the top as our base 1. So what is the distance of the top? Well, luckily it's a straight line, so I can just count it. So 1, 2, 3, 4. The top is 4. So base 1 plus, what is base 2? So that would be the other base. Let's count that. 1, 2, 3, 4, 5, 6, 7, 8. All right. Now you can either just put that straight in your calculator. We could solve it by hand. 4 plus 8 would be 12. So let's just put it in the calculator. 1/2 times 6 times 4 plus 8. And that gives us 36. All right, so the area is 36. All right, and I'll rewrite that right here. Area equals 36. Okay. But I still need to know what is the perimeter of this. So again, in order to find perimeter, that's going to be all my sides added up. So I know the top and the bottom, but I don't know these two sides. Again, I'm kind of lucky in the way I drew this, that these two sides are perfectly even, and I intentionally drew them that way. It is not always going to be that way. So for the sake of this video and for the sake of time, I'm only going to have to find one side, because I know whatever this side is, that side will be also. But when you're taking a test, you cannot make that assumption, okay? So you'll need to do this side and then also that side. So just be mindful of that, just like we did here. Again, I need to know the distance from this point to this point. I can't just count because it's a slanted line. So I rewrote my distance formula right up there. So I'm going to use that. I'm going to note what these 2 points are. So I know we'll just pick this one first. You could pick that one first, or you could do this one and this one. Doesn't matter. Okay, you should get the same answer. So -4, -3. And the other point is 2, 3. All right, so take the time to label. This is x1, y1, x2, y2. Save you some headache. All right, let's fill in our distance formula. So it would be our x2, 2, minus x1, so minus a negative would be +4, squared, plus y2, 3, minus y1, again, minus the negative becomes a positive. Okay, and let's put that straight in the calculator. So I'll have the square root of 2 plus 4 squared plus 3 plus 3 squared. Okay, and a long decimal, we're going to round to the nearest tenth, so we'll do 8.5. So D equals 8.5. So all that tells me is that the distance from this point to this point is 8.5. Okay, and I already said I purposely drew this equal so that this point would also be 8.5. So now that I know the length of every single side, I can now find the perimeter. I just add each of them up. So we've got 8.5 plus 8.5 plus 4 plus 8. So just the outer lengths. Right, and that would be 29. So that tells me my perimeter is 29. Okay. A campus located 2 miles east and 1 mile south of a parking lot. A waterfall is 4 miles west and 3 miles north of the parking lot. Find the distance from the waterfall to the camp. Okay, so we're going to make the assumption that the parking lot is right here, right at the origin. Okay, so the camp would be 2 miles east. Now we got to remember kind of our compass directions, okay? So it's good to remember that up would be north, okay? To the right would be east, to the left would be west, and down would be south. Okay, that's kind of information we're expecting that you would know at this point. Okay, so from the origin, from the parking lot, the camp is located 2 miles east, so that would be 2 units to the right. So 1, 2, and 1 mile south, so moving down. So that tells me that the camp is right here. Camp is here, parking lot's here. Now it says the waterfall, I'll do that one in blue. All right, the waterfall is 4 miles west and 3 miles north of the parking lot. So we're starting at the origin again. So 4 miles west, so that would be to the left, 1, 2, 3, 4, and 3 miles north, 1, 2, 3, would be the waterfall. Okay, and it specifically wants to know the distance from the waterfall to the camp. So from here to there, what is the distance? Okay, so I've got 2 points here, and essentially they're just asking me to find the distance. They're just doing it in kind of a complicated real-life application way. So I have my 2 points. So the first point was -4 and 3, and the other point, the campsite, was 2, -1. Now, I'm just going to use my distance formula to find the distance between these 2 points. So remember that distance, we should know this by now, we should be having this memorized at this point. x2 minus x1 squared plus y2 minus y1 squared. All right, so all we need to do is label our points, plug them into the formula, put it in the calculator, and solve. All right, so this is our first x, so we'll call this x1. This is y1, x2, and y2. So for our distance formula, d equals square root of x2, 2, minus x1, so minus and negative is plus y2, -1, minus y1, 3 squared. All right, I'm going to put that directly in the calculator. So, parentheses 2 plus 4 squared plus -1 minus 3 squared. All right, and that gives us 7.2. We're just going to do to the nearest tenth. It didn't specify, so I'm just going to use common sense and say nearest tenth. All right, so 7.2 would be our distance. And we're talking about miles, so it's 7.2 miles from the campsite to the waterfall. All right, let's look at another example. A mall is located at point -3, 1. A restaurant is located at 4, -2. What's the halfway point? So maybe you live halfway between the mall and the restaurant. Okay, so first let's plot the mall. So that says the mall is at -3, +1. So that would be right there. All right, the restaurant is at +4, -2. So it would be right there. Now this time it did not ask us to find the distance like it did in the last time. It wants to know what would be the halfway point of those 2 locations. So you can go ahead and connect them just so we can kind of visually see this. We're going to have to use math to solve it though. I can't just say, oh, that looks like about halfway and plot the point there. We've got to be really specific. So to find the midpoint of something, we use the midpoint formula, which we learned, that was the second video in this unit. All right, so midpoint formula is x1 plus, I had to remind myself, plus x2 divided by 2, and y1 plus y2 divided by 2. That is the midpoint formula. We should have that memorized at this point. It might help to just rewrite your points So -3, 1, and 4, -2. And let's label them. So we'll call this x1, y1, x2, y2. And we'll plug them in to the formula. So we've got 2 big parentheses, x1, -3 plus x2, 4 divided by 2, and y1, 1 plus -2, which is the same thing as saying -2 divided by 2. All right, now remember, it's important that we simplify the top first, then divide by 2. Okay, that's very important. We don't do this divided by 2 and that divided by 2 and then add them together. Nope, we're going to simplify the top first. So -3 plus 4, that would be 1. And 1 divided by 2 is just 1/2, or 0.5. Okay, 1 minus 2, that would be -1. And then -1 divided by 2, well, that's as reduced as it can go. That would just be -1/2. Okay, so that is the midpoint. So I would have to go ahead and plot this at +1/2 and down -1/2. So it would be right here. And you'd want to check and say, does that look like the midpoint of these 2 points? Yeah. So that's reasonable to say that the midpoint, the halfway point, would be at 1/2, -1/2. All right, this has been Miss Smith's Math Tutorials.